structure, and strict operational and validation controls are mandatory. So this is some regulatory framework. I didn't mention ASHRAE, but of course ASHRAE has a very good tools, a very good guideline how we design clean rooms. The pharmacy is absolutely clean rooms, and I don't remember the TC committees. It was in February, but I participated there. Conrad is not here, but he is one of the leader there. So also they going to publish a new guideline how to design clean rooms. So these are mostly the European regulations how to design it, and the most important is to understand that we are talking about clean rooms, but those clean rooms are based on grade level and not on class. If we take class 100,000, which is relevant or parallel to ISO 8, or class 10,000, which is parallel to ISO 7, and so on. So in the pharmacology, we are talking about grade. Grade is the highest level, which is close to, let's say, ISO 4, and grade B is like ISO 8. And now you can see also what is the required speed in the room, the velocity, and also how many air changes we need in the room in order to succeed to create the cleanness of the room. So in grade D, we need a minimum 20 to 30. As I told you, it's parallel to ISO 8 or class 100,000. Grade C is 30 to 50. Grade D, which is the preparation room, is 60 to 100. But the most important issue is that in those pharmacy, we are using 100% ventilation, no recycling. Okay, so it's one floor, we bring the air from outside. We spoke about ASHRAE 214, we are speaking about decarbonization. In this case, we are working on 100% makeup air, and we know makeup air is the biggest consumer of energy from air condition aspects. So this system is very important in terms of filtration, in terms of maintaining the temperature and humidity, and Stavros described before some ideas about our human body behavior in different conditions. So it's very important to maintain the humidity and to maintain the temperature in the halls. So this is again a big challenge to design a proper air handling unit that is able to overcome all the conditions. And conditions are variable because it's outside air, it's varied between day and night. In some places in Israel, we can reach 80-85% of humidity in the nighttime, okay, and low temperature, or sometimes in the part of the country we have also high humidity and high temperature. So it's again, it's good engineering for us, and we know how to deal with that. Okay, also, we also classify the room and the grade according to the size of the particle in the air at rest and in operation. So it's depending on the size of the diameter of the particle, which is 0.5 micrometer. So at grade A, we are talking about 3,520 at rest. It's the same at the operation, but as long as you go to higher grades, then you have different compromise between the number of particles that we are checking. So the core design philosophy is to protect the patient from contamination. It's very clear. Protect operators from cytotoxic exposure. Protect adjacent areas and environment, therefore we maintain a positive pressure. Maintain robust containment during abnormal condition. Provide maintainable and validated system. Typical functional layout, maybe I will jump it because I have some drawings. So this is the drawings of a typical pharmacy. You can see that you are These are the So this is the main entrance, storage, change room. We come in, and these are the two main rooms. We have a passover chamber here. Here we have the BSL hood where we made the preparation of the toxics and all the medicine. Then we transfer it here, and here they prepare it for delivery to the oncology department or the place that they are giving the injection. Okay, so this is a story that show you when we design such a kind of facility, how we make not only the design of air conditioning, but we put a lot of energy and attention to the dimension of the room, all the finishing, all the equipment that we are going to install. Everything should be very smooth and clean, very similar to clean rooms that we are using in the microelectronics, but it's completely different. So, clean room classification strategy is ISO 5, which is very similar to grade grade B. This is the B.Sc isolator. You can see the chemical hood. It's not a chemical, a biological hood. ISO 7 is for the cytotoxic buffer room, which is the grade B, and ISO 7, grade C, ISO 7 or ISO 8 is for the anti-room, which is grade A. So, continuous particle monitoring is also recommended in such a kind of building. Therefore, there are several testing during the year. There is a special protocols that you have to bring external companies that make all the measurement of the room. Of course, this is a clean room, so we are using HEPA filters, H13 or H14. It's 99.997. So, very interesting things and a lot of investment in such a kind of small facility. Normally we are talking about 12,000 euro per square meter in such a kind of facility, because at 50 or 100 square meter you make the calculation how much such a kind of facility costs you. The airflow visualization is also required. And then comes the pressure cascade. The pressure cascade is according to the necessity of the room and the grades. So if you see in the table, there are different levels of pressure according to the rooms that we are taking care of. And this pressure is going from the lowest level or the highest grade of cleanness, which is about 30, minus 30. Also, sometimes we are asked to provide a higher level of pressure drop, but it's making a lot of troubles, because if you pay attention, you have the BSL chamber. So, if you have minus 40, for instance, okay, then it's create the opposite flow from the BSL to the room. You don't want it because you want to protect the workers. So therefore, we reduce normally the condition to minus 30, to minus 27, but the most important thing is to keep the cascade of pressure between different spaces in the pharmacy.
5 minutes.
Oh, good. Okay, so I spoke about the construction and the tightness. You should make a very sealed envelope. If you know you don't have any chance to create the under pressure or the positive pressure. So all the structure is normally made of HPL. It's a special sandwich laminated clean room panels. Must be very smooth in order to avoid any contamination on the wall. All the sockets and all the light fixtures should be suitable for clean rooms. Okay, and we don't allow to have sharp edges, we need round edges to avoid any contamination and collection of particles over there. So the ceiling is also very important thing because once you don't keep the ceiling tight, you will have a leakage of air from the space, from the plane above the ceiling, and then you lose the control. Okay, so there are some leakage target typical, which is 1 to 2 cubic meter per hour per square meter at 50 Pascal pressure. Okay, door frame, HEPA housing and penetration are key risks. Okay, all the sockets, all the elements, we have sometimes gases that are coming from outside into the laboratory, into the pharmacy, so all the penetration must be 100% sealed. And always when I'm coming for commissioning, I have a big fight with the contractor, and I show him, listen, here you have to seal, here you have to seal, if you have to seal, because it takes sometimes 3-4 times until you come to the final results. Okay, so this is a layout we put normally when we design the HVAC, we design the PNID system, which show you the air handling unit. So you can see the air handling unit, you have all the devices. This is the PNID, bring you to the BMS system, because it's such a kind of system, if you want to control the pressure, must be very accurate system. We are using AI technology also in order to make a machine learning that can understand how the system is running, because once you open the door, the pressure is changed. So we have to decide how long time you give the system to recover, because you open the door, pressure change, and then you have to recover the room. It should be no more than 20 seconds. That's what we are doing. This is another part, because we divide the equipment. We never make one unit for the entire pharmacy. We divided it. Sometimes we are making 2 machines if we have enough money and budget to do it. And of course, the exhaust is going by BIPO filters, okay? Because it's one way. You bring air inside the spaces and then you suck it, and the balance between the exhaust and the supply create the pressure drop. And the last thing is I jumped it because I spoke about it. You can see part of the devices. Okay. This is the pressure-independent valves that we put in every one of the rooms. Those pressure-independent valves are making sure that the pressure drop will be very accurate, and it's also connected to the BMS system, so we have a full view of what's happening in every penetration of the air into the system. There are different devices. This is American system. I'm not going to promote it, but it's a very good product. We are using it in Israel. And also there is a alarm philosophy. Once the pressure change below the certain set points, you need the alarm. Maybe there are some problems. You can see it on the BMS, but don't forget that the BMS is coming to the maintenance people and not to the operator of the pharmacy. But then you get alarms and you know exactly that you have some troubles. Okay, so these are the critical design changes: balancing, sterile, door leakage, recontainment during HEPA filters, cross-contamination prevention, which I spoke about, that pressure stability. It's very important. We don't want any variation. Once you put it on 30 Pascal, keep it. So this is, there is another point during the commissioning. We call it qualification and validation. So there is a set of testing, design qualification, DQ, OQ, IQ. I believe that if you're in this business, you know what does it mean. HEPA integrity testing is very important. Airflow smoke visualization. You're going to see that the air is going in a laminar flow. pressure cascade, and biological monitoring. And the summary is that the cytotoxic pharmacy design requires multidisciplines integration, containment and sterile must coexist, pressure cascade is a critical safety barrier, URS and basis of design define project success, HVAC design is central to compliance and safety. I didn't mention what is URS, but the user requirement system. It's a protocol that the client is writing before we start the design. Okay? And in this URS, it put all these requirements, the design condition, the pressure code, whatever you think, that is, you as the doctor, you are doing the job, and we are giving the solution according to the URS, we give the BOD, and these are two important protocols that you have to keep them, and if you are going to change the URS, somebody is authorized to do it, not everybody can do it. Thank you so much.
Go online, do the Slido, do the evaluation, and any questions from the audience? A quick one, Avi, from your experience in the hospital, what has been the most challenging task, area, part of the hospital that engineers are usually having the greatest challenge?
The things that everything that relating to laboratories, pharmacies, such as this, and all the diagnostic systems are very important because, for instance, the diagnostic machine or nuclear medicine, they are asking today to maintain a very, very clean conditions and also very accurate temperature and humidity because of the machine and the accuracy of the machine. And this is a big challenge. So the regular around, maternity, etc., it's been good money to the hospital, but it's not a big challenge to them. But these are the main issues. Or the angio, if you know, the brain angio, you have heart angio, these are very challenging tests. And every day we find new machines that are coming to hospitals, more modern, everything is more complicated, more sophisticated, and also the results. You know, in the past, you made an MRI or CT, you didn't know that you have tumor in your body, but this tumor not damaging the body. Because of the high resolution of the equipment, you are getting more information about your body, and it's creating a lot of work. So, this is the challenging that the doctors also must be much more sophisticated and professional in analyzing all the results. All the radiology is very important now, and this is the future.
Thank you so much.